You're here to learn a lot about security today. You're all obviously interested in GlassFish. That's a good message. I really love that to hear. We brought a little bit of an agenda today. I hate doing that kind of stuff in presentations, but yeah, I had to. So we're talking about roughly 3 topics today. A little bit like warm up for our speakers to get used to you, to get into the mood of speaking. Then we have the main session content that talks about the 10 most important security flaws you probably are going to face with your applications, and furthermore, and a little bit of a takeaway just to keep you entertained and happy. As I said, I'm the yellow one today. I'm Markus Eisele. Right beside me is Masoud. And yeah, I don't know if you would like to introduce yourself a little bit.
Yeah, okay.
Come on over.
I'm at Oracle at GlassFish team, and before joining GlassFish team, I wrote a book on Java EE and GlassFish security, and that's the subject that I like. I usually blog at that blog address that you have there, and tweet at the Twitter address that you got there. So if you're interested, you can just follow that and take some blogs that I write on security and GlassFish and Java EE in general. Thanks. I give it to the ace.
Okay, the ace is obviously the friendly one. Oracle is the, yeah, I mean, you all know red. No, I'm just kidding. We love Oracle. That's why we're here, right? Thank you. Okay. What am I doing? I'm part of the Java EE ecosystem since a few years. Few of you probably have seen me before speaking around at some conferences. I try to extend that whenever there's a chance. You've probably seen me on Twitter. My account name is MyFear, so yeah, whatever you like to know and keep updated with security, Java EE, and GlassFish in general, just take a look there. The session title holds something like security with GlassFish. That is a little lie. I mean, we're talking a little bit about GlassFish as a kind of an example, but obviously everything we show you today is not tied to GlassFish. It's tied to Java EE, so you end up using some kind of container. Honestly, I don't care if it's GlassFish or not, if it's WebSphere, if it's JBoss or whatever is out there. So take it as an example for things to look at. We all love GlassFish, by the way, so it's a reference implementation. You have the tightest and freshest bits available during the whole time frame, even the specification development. So whenever you have a chance, just take a look at it, glassfish.org. Yeah, talking about security is boring. Not for the speaker. I mean, we're always excited to be in front of all of you and have the microphone here and do some stuff, but yeah, for the audience, it is boring. So I thought I'd try to introduce a nice example. How many of you have heard about the Galleria Java EE 6 application? Nobody. That's a surprise. We don't have a lot of good examples out there, full-blown examples about what Java EE 6 is able to deliver. You've all seen the Java tutorials. What's your impression? Yeah, that's mine. I mean, it's a very slight example, and the Galleria is done by Vinit Reynolds, a fellow friend of mine, and yeah, he tried to do some domain-driven approach with Java EE 6. And by the way, he developed a not too trivial, very nice application which is freely available under Apache software license. So you can take a look at it. It's running down on Bitbucket. And I also did some documentation on how to set it up and get it running. The big issue here is testing. So the complete project also contains a good set of Achillean tests you can also run and have a good experience with that. I'm definitely not going to show you the Galleria in action today because that is not the main goal. But what I'm going to show you is how Galleria looks like if you take a first look. And this is obviously the domain model, the core entities you see within the Galleria project. That's not much. It's very nice, but we're talking about security today, right? You noticed that one? How are you feeling looking at that kind of things in a domain model? Who's feeling comfortable today? Nobody? Okay. Any good idea? Laird, come. You're the only one I know. Come on. You're feeling good with that? Yes or no? You're not. Okay, perfect, fine. Let's look at the architecture. I love some fancy tools out there. This is done by Structure 101 without any more tweaks, so this is what comes out of the tool. Do you notice any security-related stuff there? Not really, right? I can promise you there isn't any, so no modules, subcomponents, or whatever you like to call them, that actively care with security. Let me give you some more information about Galleria in general, just to keep you warm. We have kind of a form-based authentications. We're using a JDBC realm behind that. And we do a fancy feature that's called programmatic login within GlassFish. So all the backend is secured by roles allowed annotation. So what's that? Is that good? Is that enough? Do we all feel comfortable with that? Who's feeling comfortable with what he's seen from the Galleria until now? Nobody. Surprised. Who is feeling really worried about the Galleria? At least 2 hands. And all the rest is kind of, don't know, right? Okay, fine. Yeah, let's look at that a little bit deeper. What was the motivation behind that talk? The basic idea is, yeah, we would like to share what we know. Security is kind of a boring topic. And don't count me for one of those people are really interested in being boring or talking about boring things. So, but what I actually do is I see a lot of stuff out there. I'm part of a research and development department, and we tend to come in when people hit the walls. So our only job mostly is just to fill the holes in the walls after the project's left up. So yeah, and that tends to be 30 projects a year coming down the road with different kind of problems. Not all security related, but enough to share some of the insights. And I know a good percentage of the problems could be solved by people like you by being aware about them. Just front up. You're not having to love security up to the deepest holes, but you should be aware about it. And that's the main goal of that talk, just to point you to the top 10 issues. And yeah, beside that, I'm obviously going to solve that Galleria puzzle for you today. So I'm really curious to see how your impression was. Talking about the top 10 flaws isn't easy. As with all top 10 lists, you have to find any kind of reliable source. This is a good first draft, I guess. Who has heard about the OWASP guys? Okay, they're caring a lot about web application security since a while, exactly since roughly 2000. So they have a lot of stuff to offer, a lot of boring stuff, a lot to read, but also some more practical hands-on APIs and libraries. So those guys publish a top 10 list year by year. So it's a good idea to just look at what they have. As I said, it's a top 10 list, so you could expand that list by any number of items you'd like to. So this is really a first tip of the iceberg to look at. Yeah, that's what we're going to do today. We are getting through every single one of those 10 steps, and I try to present what the actual attack is, what the security flaw is about, and then we look at it, how to prevent it. Come on in. Yeah, happy. Okay, injection. Who heard about injection before? Okay, anyway, that's a quite popular topic. I'm surprised to see that on number 1 still. I mean, it's not that nobody knows about that kind of things, but it's all about manipulating data in any form. So whatever interface you expose might be a user interface or some kind of service to based on any technology you know. It's all about manipulating the data behind that, doing some unintended readings, doing some unintended manipulations, dropping tables, and all that stuff that really isn't nice. You basically have two areas in the Java EE space in general where they could affect you. That's more likely the validation side, all that happens on the UI if you have a user interface, and this is definitely the database, the data layer stuff. Okay, what could you do to spot that? This is one of the examples everybody knows in every security awareness practice. You could even achieve that kind of stuff with JPA, which is by default very safe, but you still could use some really fancy methods out there to do things that you shouldn't do. So if you come across some kind of unvalidated user input that directly goes into your SQL selects, that's definitely the good idea about having a problem here. What you can do about that? Obviously, first really important part is sanitize input. And that is for a good reason the first point here. You probably come across this on other slides also, but the basic message is don't trust any user. There are no good users out there. They all try it. They all try. Even you tried that before. I mean, you've seen some fancy idea that obviously pulled some fancy file from any of those fancy download sites. So you try to change that number, right? I mean, you even try to access some other usernames via their URLs or get at the data. So we all do that, and everybody is doing that. Do whatever you can to prevent that. That's not easy. I'll show you in a minute, but that's the first basic stuff. Another good idea is to escape and quote safe, whatever you have. So not only doing some very high-level sanitizing, you could also simply put all you get in there and escape it until a decent amount that it no longer hurts you on the database. Bound parameters are obviously the best idea to use here. I've talked to security guys, real security guys, those working for the FBI or any of the other organizations out there. They are insane, and they come up with really high security solutions, and they wouldn't even mind if we use some kind of prepared statements and doesn't do anything with the user at all, or at least don't do anything in the middleware. So if anybody comes up with you using some prepared statements or whatever, yeah, I mean, prepared statements is fine, but what about stored procedures? Yeah, that's it. I mean, whatever you can shift to the database, do it. Another good idea is to configure the reporting accordingly. I mean, just look out for that kind of flaws, that kind of attacks. Try to find a way just to bring that to any error log so that you can have a look at. Cross-site scripting is probably one of the most well-known attacks out there. This is not about injecting data or manipulating data in the first hand, but injecting some kind of malicious code into what you have in your own user interfaces to get access to some security relevant information stored in cookies, or at least the HTTP session, which is kind of a key to your application. So you could do anything on behalf of any user if you know its HTTP session ID. So that's a real big misconception. The technology you should look at, that's obviously the JSF or JSP or whatever UI technology you're using here. What could you do to spot some kind of things? Look out for explicit settings that do set anything that sounds like escaping or sanitizing to false. You could even do that with JSF. JSF itself does some kind of sanitizing. But beware, they only can be that intelligent like somebody put it in the framework. So make a good guess about what's doing that line below. what's happening? What's happening if somebody clicks on that link? Any idea? That's definitely also kind of cross-site scripting. So even JSF doesn't know that kind of data text insert and obviously doesn't sanitize it. So I could do a lot more with your applications than you ever thought of. And I believe you thought they are safe. So keep a good look on every kind of weird data that could come from the client. And yeah, the top 1 point, sanitize it. And if you haven't learned that already, only safe escaping and quoting probably isn't enough. There are a lot of more good frameworks out there. One from the OWASP guys, and they have a good coverage of all the most common problems you experience, even if I don't believe that they get those inlined HTML or text data encodings right. But I mean, that's probably a thing to look after if you're running around that topic. Number 3 is my absolute personal highlight. I don't know, who of you ever had to do with kind of high security applications in Java EE? Okay. Then you probably know what I was going through while developing something like that on my own on behalf of a customer. So we had really fancy data in it. That was kind of a trading platform for industrial insurances. That is basically some stuff no insurancer would take without doing a kind of a 500-letter contract on that. So those are the contracts behind the World Trade Center fire insurance. Okay, it's not a good example, but you know what I mean. And you heard about all the stories behind the World Trade Center and their insurers and what happened after everything went down. If you don't work securely and safely with what you have, then you could screw up a lot. So it's all about doing the right things with the configuration of the security itself. So it's about how the container validates security information. It's all about your passwords, how you store them, how you generate them, which encryption mechanisms you use, and it's all about the number of factors to authenticate. I hope you're all using Google Mail and you all added the second factor authentication there. I mean, that's a good starting point. Mail is very sensitive data, and you could say what you want, but having a second factor in place, you have to carry with you. Nobody else has, is a real good and secure requirement. But at the end of the day, you have to take care for that. There's nothing Java EE could do for you out of the box to enable that kind of features. So you would have to look at what the container provides in terms of frameworks, Jazz or JazzPick, and some even could come up with their own solutions, a kind of a servlet filter approach. So how would you probably spot issues with that? That's a good question. The obvious place to have issues here is using HTTP without any transport layer security at all. I don't know if you're aware of that. HTTP isn't encrypted at all. I still see people running around, HTTP is safe. It's definitely not. Try to attach a sniffer to your network interface and see what's going over the wire. That's clear text. Another good point is custom security implementations. I've seen them all. And some of them, really fancy stuff. Big libraries, very decent APIs. But who tested them? Did you develop that on your own? Did you use a third-party library? It all depends if you're brave enough to use that. If you have a high security implementation, then you probably want to stick what anybody has to offer. So whatever is out there as a third-party library, yeah, that could be a big flaw. What else do we have? Password strength requirements. I still see pages around there requiring people to enter passwords shorter than XX characters. I don't know why they do that, but that also could be a good indication about a security problem in an application at all. If you're thriving up the wall and you have more higher security requirements, then you probably would end up having to manipulate the HTTP session handling mechanism. You know that the HTTP session, if it's authenticated in some way by the container, is your key to the application. So all the container does is checking if that session is still valid so you don't get re-authenticated with every request. If I come across the wire, sniff a little bit at your network interfaces, get your HTTP session ID, and fire up a request against the container with your ID, I'm basically you. So you have to find any idea of binding additional information to that session. That could be anything. That could be kind of a browser footprint, you know about remote IP addresses, everything that distincts the requests from each other. So if you don't have any additional HTTP session bindings mechanisms in place, that also could be a good place to look at if you're looking for security flaws in that category. Who's testing security in their project? Oh, okay. Which cases, if I'm curious? Only the admin cases or the complete security matrix?
We scan our entire application. We actually have a small penetration test.
Okay. And in terms of unit tests, do you do role-based tests?
Yes.
Okay. Okay. You're definitely at the 1% level. I mean, 99% of the projects out there simply have some admin workaround and only do all the unit tests with an admin account only. So, yeah, switch that. Be a good programmer and try to add security to your automated testing. As I said, use what the container has to offer. In the terms of GlassFish, that are probably the security realms that are already out there. There are some pre-configured ones. I don't know if Masood is digging into that later, but as you've seen with the Galleria, JDBC realm also is one of those standard realms they're using. If you actually have custom security stuff in place, please do test it. I mean, don't accept it would be nice and simply work. It doesn't. It's software, even if it's security related. And transport layer security is mandatory, okay? There isn't a way around that. You could use some kind of fancy additional cookie flags, but honestly, yeah, that doesn't work. And it's not a solution as a single point of thing to do. A4 is something that actually does influence you as a developer. This is all about those fancy REST-style URLs where you start accessing domain objects with their direct ID references. So whenever you have some kind of URL, get a user number 21 or user number 1, then everybody is trying to play around with that. And it's quite easy for an attacker or possible attacker just to make a good guess and find out about ways to tweak that. And it also opens every door for parameter value tampering. So yeah, that's basically what it is. You find that in all layers. You could do a lot. How to spot that? Have a look at the data separation on your database. Do you actually have some kind of tenant separation? Some fancy where IDs, so looking at customers or whatever? If not, then you could probably run into trouble here. Do you have any kind of request mode data access controllers, something like that in place? Looking at who should read its own data, who should read data in general. If you don't have them, you probably have found a place to look for security flaws. What about additional query constraints? If they are not there, also a good place to have a look at and probably add some more if you don't have them. You could do a lot to prevent that. Everybody is recommending to do some kind of a access reference map here. The idea is basically to have any kind of obfuscation, so no direct reference to the objects behind in your database. You could do that randomly. You could do that any way you like. So instead of showing that, you would show something like that. Instead of showing that, you would show something like that. I don't know. I don't like it that much, but it's obviously a good way and a safe way to do that. You could also do some additional validation on the parameters that were passed into those features. You could use some kind of a data-driven security approach. I don't like all that stuff because it's not backed by Java EE standards in any way. That's one of the biggest drawbacks I tend to see in recent Java EE implementations, that we don't have lots at hand to address those top 10 security flaws. I mean, we're not talking about the fancy little 5 things in the corner. Those are definitely the top 10 risks you have with your application. So especially at this one, you don't have anything to support you. Take a good look at it and spend some more minutes to think about the concepts behind that. Data-driven security is probably the best way, but it's also the hardest way to implement. So I couldn't make a good guess what would be the best solution for you. That's already my last slide from my half, right? Nearly through. So you're probably digging into the GlassFish server stuff in a few minutes. Who ever heard about cross-site request forgery before? Oh, that's actually far more than in the Scandinavian area where I've been last given that talk. Yeah, it's, as you might know, a capture replay attack. So anybody is sending you any prepared link and you execute it within the scope of your actually authenticated session, and those attackers do force you to do stuff with your actual session which you shouldn't be allowed to do. The more deeper links you have in the application, the easier it is for the attacker to identify his goal, identify the relevant URLs, the easier that stuff gets. This is more or less only UI relevant, so you could try to spot security flaws like this. The obvious flaw is that you don't have anything in place about that, or you simply don't know about that kind of risk. Also, some kind of fancy secret little cookies that get set by an application somewhere might be a good hint that somebody was thinking about that, but simply doing it wrong. Also, another good prevention technology you find out there is that somebody decided to switch all the application requests to post only. That's completely weird. I mean, it doesn't matter in terms of sniffing if it's a post request or a get request, so that doesn't help you at all. But is been used as a prevention method quite a lot out there. Others think about doing some kind of wizard-like transactions. So you simply have a first step where you identify your bank account, a second step where you enter the amount you're going to transfer, and the third step where you actually do the transferation. But as you guessed, that also doesn't work. I mean, we could do capture replay on that too. Simple URL rewriting, also a nice and decent way to try to protect you from that. All those ways doesn't work, but you have a good place to look at for that kind of security flaw. What you actually should do is add some kind of unpredictability to your forms. Do something that make your forms unique. Do this by adding any kind of token, and you could do a lot of stuff here. You could even develop some hidden token. You can use some kind of unique URLs and add some kind of token to the URL parts. You're very open in the way to implement that. It has a big influence on the usability of your application. Whatever browser navigation is out there is broken with that approach. So keep that in mind. But that tends to be a general topic with security in general. The more secure things get, the less usable they get. try to be the mediator there, okay? Keep in mind what kind of stuff you have to protect and find the right solutions to your protection needs without breaking usability at any kind. You could do that by your own, which you obviously shouldn't. If you would like to, have a look at my blog. OWASP also has something in stock for that. And if you have some time and you're using JSF 2.x at the moment, then you're probably willing to wait for what E7 has to offer with the JSF 2.2. There we'll finally have some out-of-the-box solutions for that problem already. So they are basically adding some kind of token to the form components and would save you. Another good idea you could add here is prevent those double submits by users. So that's also a good area to add here in that point. Now it comes to configuration. That's obviously something GlassFish has to offer, right? No, it should be every application server. So I just hand on to you, Masood. Have a great time.
Okay.
Yeah, sure.
Okay. Security misconfiguration, probably a common source for many of the security flaws that we saw here and there, and that is the first topic that I'm going to cover between the 10 top security concern for OWASP. Okay, the misconfiguration can apply to lots of things, but basically it can be at operating system level, which covers the file system, the user management, and anything that can be restrained for a particular user. It can be at your middleware or application server level, or it can be at your database or any other service that you're hosting or you're providing or you're running to address a request that the user sent to your system. What it includes, really, it includes everything, because any kind of misconfiguration can be a source to a security breach. But basically the most important one are the ones that are directly related to security, which includes something like listeners, file system, user permissions, the way that you authenticate, etc., etc. Missing patches. If you're running a middleware or any kind of other services, it's a good idea to be up to date with the latest patches, because a patch may bring some new updates to cover a security hole that already exists, or it may bring some updates that may prevent someone to discover a hole that is not already discovered. And the default accounts that I'm going to go into details into that one, and this is something that people usually tend to leave intact, which is not a good idea again. Okay, worst practices in this case. I am going to give the sample over GlassFish, but you can extend that to any other service that you are running. The worst thing to do is to not creating a user for each one of the services that you're running. If you're running a GlassFish and an MQ and a database on the same box, the best idea is to have separate users for each one of those and make sure that each one of those users is properly restricted from accessing any part of the file system that they do not need to access. So if you're running GlassFish, GlassFish doesn't need to take a peek at a directory that you have your bash data coming every week. So if for any reason or for any kind of flaw in an application deployed in your GlassFish, someone get breached that, then they won't be able at least to take a look at your data. That what they are going to get is what you have with the GlassFish user and not everything on your file system or on your network or anything of that sort. Network interfaces and socket access control is something really interesting to take a look at. Basically, I'm talking about GlassFish again, but it can be extended to other application server and other services that you may install. They usually listen on 0000, which means that all interfaces that are available to this particular system are going to be bind to the socket that GlassFish or your service is going to listen to. So if your machine got 4 interfaces and you're running GlassFish on that, GlassFish is going to be bind to all of those 4 interfaces. Let's say that one of them is in your LAN, one of them is going to be connected to your WAN. There is no reason for GlassFish that is going to listen for the LAN request to be binded to the socket that is connected to the WAN. So basically what we do is at GlassFish level or at your middleware level, you should take a look at the socket address that it is listening on and ensure that it's listening on the right one, not on all of them. relaxed file system access control can be another good flaw. As I mentioned, we usually create a particular user for each service that we are running, and it's usually on a Linux machine, not a Windows machine. And you can have all sort of access control on the file system. You should put a quota for the user to ensure that it's not going to just eat all of the disk space. If there is a flaw somewhere in the logging or anything of that sort, it's not going to cause a problem for the services to stop functioning because the disk is running out. Using the defaults, the default, almost like all of the services come with an administrative user, and the administrative user usually have a default password. I don't know, welcome1, admin, or whatever that is. It's a good idea to completely remove the default user, which is named admin, with a whatever password. Remove that, put that aside, create a user of your own with the name that you prefer and with a password, complex password that you prefer. So no one should be able to guess that if you are running e.g. GlassFish, you have a default user with the admin, which is going to have the administrative right on your GlassFish. Just remove that and create a new user with a new password and use that. Network interface, I already explained, and then certificates that you may use for your outbound and inbound connection with your clients. It's a good idea to get a real certificate rather than self-signed certificate which comes with your middleware, because people need to trust that they are connected to the right host, not something that shows that little red thingy on your browser. So get the right certificate and install it in your middleware or your web server or anything you have. I am sure that you will find how you install the certificate for GlassFish, because there are a fair deal of data on that. Okay, and finally, using not a hardened OS. That's something that Marcus likes. Make sure that you are using an operating system that is suitable for serving as a server, not an operating system which is suited for the clients. I already mentioned that you can restrict your middleware or your services at operating system level by creating a user for each one of those services and then restricting that user to whatever you know that the user should have access. That includes the file system, that includes the network interfaces or anything of that sort. But that doesn't mean that you should not take other precautions. Java SE provides you with something called a security manager, and the security manager can take care of permitting or not permitting a specific set of classes perform a specific set of tasks. So a policy file, you can use a policy file to say, okay, I don't want this particular jar, which is not signed, to have access to the file system, or I don't want this set of jar files to perform anything like system.exit or system.exec to execute something at the shell level. There are 4 policy files that you can tweak, and we usually do this at the more generic one. We put less restraint, and as we go to get more particular, we add more restriction to ensure that the wider restriction is not going to affect everyone. So the first one is the global policy file, which is located under that directory. The second one is the user policy file. If you have a JVM that is shared between multiple users in the system, you can tweak the policy file for each one of these users to make sure that the permissions that are given to that particular users are the ones that the user require. Then we come to GlassFish. At GlassFish, we have a domain-level policy file, which let you tweak the permissions that can be given to the codes that are being executed at a one particular domain. And finally, we have something at application level. So if you have deployed several applications in a domain and you want to fine-tune that the permissions that is given to one particular application, you can use the granted.policy file, which is located in a directory that is like noted there to ensure that, for example, application A doesn't get a chance to open a socket, or application A doesn't get a chance to run system.exec or system.execute. For GlassFish, another thing is to use the latest version always. Enable secure admin. If you are going to use the CLI to remotely communicate with GlassFish, make sure that you enable the security for the admin service. Admin service is a RESTful service that is running in GlassFish, and the CLI that you are using is going to communicate with that service. If you do not enable the security for that, the communication that is happening between these two is going to be on clear text, and clear text as explained by the ACE, is going to be easily sniffed. GlassFish provides something like password aliasing, and it is, I think, provided on all other application server. At least I hope that is that way. Password aliasing lets you store the passwords, for example, a database password that is going to be used by a connection pool, and you don't want that database password to be included in the GlassFish domain.xml or your middleware configuration file. You can create an alias for that, and this alias is going to represent the password. The alias is going to represent the password, but the password itself is going to be stored in something we call the key file in an encrypted manner. So no one is going to ever take a peek at your database password or any other EAI that you have by just looking at the domain.xml. So yeah, enabling security manager that I already mentioned and put forth a proper security policy file. The security policy file actually gives you this control over the codes that are executing inside your JVM. From one end, you are already applied some constraint through the operating system, and from the other end, you are applying some constraint through the JVM to make sure that no code is going to do something that it is not intended to do. And the last one that I already mentioned. Okay. The policy files, I said that the policy file take precedence. So whatever included in the global policy file can be overwritten by the user policy file, and whatever is included in the user policy file can be overwritten by the domain policy file in GlassFish, in a sense, and probably any middleware that you have can provide you with that function to override the policy file. And finally, the application level policy file override whatever included in the domain policy file. It's a good idea to document your change and write what you have done and why have you done that. So for a later time, you can take a look at the documents to see why have you added a particular rule at the policy file. Failure to restrict the URL access, that's something else that's interesting, and I'm going to cover that. As you know, URL are the address to your data or whatever resource you have at your backend. And failure to restrict the access to a URL is failure to restrict access to your resources which are sitting behind the URL. It is directly related to A4 that Marcus already went into details for, and I'm going to cover something around Java EE in that. The worst practice here is to use a homegrown security feature instead of whatever that container provides, because something that is provided by the container is already tested and proven to be properly working. So you don't need to be worried that, okay, if I'm using container security, I need to double test that and triple test that to be sure that it's working and it is doing what it's promising to do, because it's already been taken care of. And assuming that people won't know some URLs to try them, that's wrong, because people would know and they will guess that and they will try that and they'll make sure that they find something that you have forgot to put a restriction on, and they will use that to do something harmful to your application and your data. And assuming that someone won't misuse the extra permission that they got, that's not a good assumption, because generally people are good, but some people may not be that good, and if they are given an extra permission, they may misuse that. So be sure that you're properly applying restriction on every URL that you have that point to a resource that has any kind of importance. What to do to prevent A4 includes use container security, and we have security constraint that you can use, and don't be stingy with that because it's not going to affect any performance or anything. Just group your URL patterns as fine-grained as possible and assign them proper rules in a way very accurately and very carefully. Don't think that if you have 50 or 55 security constraint element in your domain.xml is going to affect anything. It's not going to affect any performance, but rather it's going to improve your security at a finer level. Use programmatic login of Java EE 6 if the form-based or basic authentication is not going to be enough. And as Marcus did for Galleria, don't go back to some custom way of performing authentication because form-based is not pretty enough or basic is not nice enough for you to use. Just do the login using programmatic way that is provided. Properly configure the security realms.
GlassFish supports XAML?
No.
No. Or XAML?
Yeah, but the point is, you can simply implement whatever you want and plug that. But it is not supported out of the box.
In a programmatic plugin. It suggests security.
The programmatic login is exactly performed the same as the form or basic, so it is just the two tokens, username and password. You grab them and you put them on, but you cannot have a SAML assertion to be used for the login method unless you know how to convert that to something authenticatable against the security realm that you have configured. Because SAML assertion is not going to be working with the JDBC layer. Because JDBC realm, for example, is to be used with the username and password. Yeah, properly configured security realms. It is something that every application server comes with some built-in security realms. GlassFish comes with a JDBC file, LDAP, etc., etc. Just make sure that you are using the right one. You should never use a file realm for production, and you should never use a JDBC realm or any kind of realm that doesn't have a proper hashing or salted hashing for the password at all. There is one thing that is interesting, and that's the way that we let the HTTP verbs to be handled. If you have a resource or a collection of resources that only support GET, make sure that you have restricted the access only to GET method and not all other methods like post, delete, option. None of them is going to be required, and let the container take care of that, and let the container handle any method that is not supported. Okay. Yeah, best practices. Any non-public URL should be protected. That's obvious. Use container authentication authorization feature or extend on top of them. All of the middlewares, at least that's about GlassFish and WebLogic, can be easily extended for adding new authentication mechanism through JSR 115 or container authorization mechanism through JSR 115. So if you know that the current out-of-the-box feature is not enough, just go and plug your own mechanism into the container rather than doing the entire thing on your own. If it is not enough, if you don't want to develop something and plug it into your container and you want to use a framework other than what container provides you, just make sure to pick the right one. Do not pick something that is not properly tested, properly used by a wide user base. Because if you do that, you will be one of the people who is going to test that, and you will be one of the people who is going to be affected by the security hole that are included or placed in that particular framework. Something. Yeah, sure.
Isn't it a contradiction first to say not implement your own stuff, and then if this is not enough, implement a plugin? Because maybe implementing a plugin goes beyond the capabilities of most people, and they will maybe implement security holes.
Let me take this one.
Yeah, okay, sure.
Definitely. I mean, the issue you have is that roll your own isn't something everybody should do. Security is quite binary. You know it or you don't. There's nothing like a junior security specialist. I mean, you only have guys knowing about what they're doing or not. So the message here is, if you're rolling your own, get somebody knowing about that. That's definitely clear. I mean, it's not like take what you get. Definitely not. Security is binary. I mean, that should be some kind of a bullet on some slide. Thanks.
Something that I should add to what Marcus already mentioned is that plugging on top of container security gives you all of the benefits that come with a container. And the most important one is subject propagation. Container will propagate your subject, authenticated subject, from one container, for example, the web container, back to the EJB container. And the same subject is going to be used for that. While if you do something completely custom without plugging it in a standard way into your container, you are not going to benefit from that. So first, do not do anything on your own. Do not implement it. Second, if you are going to implement it in a standard way and plug it into your container rather than doing your own filter, serverless filter. But if none of this is going to be enough, go and get a properly tested, properly well-received framework to take care of your security requirement. Yeah, and at the end, something that already Marcus mentioned, and that's that if someone has access to an order ID with 1, that doesn't mean that that someone has access to order ID 2. So you will need to implement that in a way that suits your application at the data level. Insecure cryptographic storage. I think we have seen about this enough. The last incident, I think, was LinkedIn with the breach that took away like a couple of thousand, hundreds of their passwords. So sensitive data being unprotected, that's wrong. Any kind of sensitive data should be protected. I'll tell you what the protection is. And sensitive data should not be exposed to the wrong personnel. It is not that, okay, I have this sensitive data and I've encrypted them, but I let anyone in the team to just take a peek at unencrypted data. That's wrong. Sensitive data can be anything that has personal value or financial value. Personal value like your healthcare data, and financial data, credit cards, passwords, and things like that. Okay, worst practices are storing the sensitive data unencrypted or storing comparative data encrypted. If you have comparative data, you don't need to store them encrypted. You need to double hash, double salt it, and encrypt and store that, because what you are going to do is to compare it with something that comes from another application or from the user. You don't need to know that particular set of data. It especially applies to password and security questions answer, because for any reason, if you have a breach and someone take a peek at those, you don't want them to have the password of all your users, because people usually tend to use the same password for all of their accounts. And the same applies for any other kind of comparative data. If you have comparative data, just double hash it and double salt hash it and let it be. Keeping clear copies of encrypted data is wrong. If there are sensitive data and you have encrypted them already, it is wrong to keep a clear copy of them anywhere. It doesn't matter, it's off-site, on-site, it's on a disk, it's on a safe, or whatever. Yeah, off-board. And the worst thing is, you have encrypted your data properly, but you are not keeping the keys or the password safe. You have just have it in a stock USB disk, and the USB disk is in your drawer. That's wrong. You should not do that. You should follow a specific procedure. I think there are standards for that on how to keep the password or the keys safe. For GlassFish, it comes to protecting the key source and protecting GlassFish accounts. Which GlassFish accounts you can protect them using the aliasing. And aliasing, again, depends on how good you are in protecting your key store. Ignoring digest or hashed password storage is another issue that you may stay away from. So if you are using any of the security realm in GlassFish, except the file realm, which doesn't support hashing, I think all other realms support hashing. Just make sure that you apply that. Identifying sensitive data. To prevent this, you need to take some steps, including identifying your sensitive data. Identifying the sensitive data is not just being used for cryptographic and on disk storage, but it's going to be used on what pages or what resources should be transferred over SSL or HTTPS, and what resources can be transferred over just data integrity rather than encryption. Wisely encrypt sensitive data on every level, so in application server, and database based on how sensitive the data is. Use the right algorithm and the right mechanism. Unless you are a good mathematician and a brilliant computer scientist, go and use the algorithm that already properly implemented and designed, not your own algorithm. Don't keep clear text copies, already mentioned that, and make sure that decrypting and viewing the clear text data is restricted to authorized personnel. And okay, insufficient transport layer protection, which a little bit tied to the previous step, which is identifying the sensitive data. I'm going to come back to this slide. This is another slide, which is Marcus' favorite. I'm going to get back to this one. Worst practices are using the basic or form authentication without SSL. That means that your data is going to be transmitted over clear text. So anyone can just take a peek at the HTTP message and take a look at your password and the username, which should not happen. Not using HTTPS for pages with the private information. You should know what pages are going to have your sensitive data, because you already identified the sensitive data. And when you know what pages contain sensitive data, you should apply proper data transfer security on those particular pages or particular URL patterns. Using default self-signed certificate is wrong. Just get a certificate from one of the CAs and add that to your application server. Storing unencrypted cookies is not a good idea. If you are storing some cookies, just make sure that you are encrypting the content that you are putting into the cookies. If you have a cookie that is going to be transmitted over an unsecure page, make sure that you have secure true, so that the cookie is going to be transmitted securely while the page is unsecure. Forgetting about the rest of the infrastructure, which I'm going to go back to. So in any setup, it is not only to have a HTTPS between your clients and outward-facing server. That's not going to be enough. If you have a multi-layer setup, you need to have proper zoning between those setup and proper protection between each layer, because if something happens to one layer, you don't want the other layer to be compromised as well. For GlassFish, properly configure HTTPS listeners, because an HTTPS listener usually use a key that you have in your key store to encrypt the data and sign it. Make sure that you are assigning the right key alias for HTTP listeners. ORP over SSL is really important. Make sure that if you are using ORP or your client are going to access GlassFish or your middleware over ORP, they are using SSL and your listener are properly configured to use the right key based on based on the alias that you specify. Enable auditing under security and access log under HTTP service. That's for GlassFish, but whatever application server you are using, it is going to have an access log and auditing already in place. So just go and enable that, and that you can take a look at your log and see what's happening in terms of when someone logged in, when someone logged out, how many times a login has failed, when server started, stopped, etc., when an EJB invoked, whatever you want. If the default auditing module for GlassFish is pretty detailed, but you can simply extend that by adding some rules of your own. For example, if a user of a particular IP has tried to log into 5 accounts in 1 hour, you need to get an email to say, okay, someone is trying to log into different accounts from one single IP. That you can simply extend the auditing module and add that functionality. The same goes for the access log. It's really easy to extend that and add some intelligence of your own to the access log. Am I going out of time? Okay. Yeah, you should do that. Okay. Group the resources. You already identified your sensitive data. Make sure that you group your resources that map to those data properly and apply right user data constraint on that particular set of URLs. And don't be stingy with that. Use as many security constraint element as you need to properly configure it in a finer grained level possible. Just make sure that you know that there are restrictions in different countries about regulations on what key lengths you can apply on the data before you send the data out of the country's boundary. You may check with the country's regulation to make sure that you are not breaking the law. Okay. Use TLS on all connection with sensitive data. Individually encrypt the message if your client server knows how to decrypt the message. Sign the messages if your client server knows how to verify the signature. Use a proven mechanism when sufficient. Okay. Unvalidated redirects and forwards. Redirecting and forwarding is something that you really need to verify and validate before performing them. Especially it comes handy when with the forwarding. If you are forming your next resource URI using the user provided values, which basically you should never do that. But if you need to do that for some reason, make sure that you properly validate the input parameter from the user, because when you are forwarding a user to a new resource, nothing is going to prevent it from accessing that resource. If you have said forward, it's going to happen. While with redirect, it's going to go through another access control check, but with the forward, it's not going to go through another access control before it's happening. So first of all, do not use forward or redirect. But if you are using that, forward or redirect formed based on user-provided parameter. But if you are using that, make sure that you verify and validate those parameters before actually forwarding the user to that particular resource. Okay. Okay, I'm done. And I let the ace wrap
Thanks
it up.
for hurrying up. Okay, let me do the quick wrap up. I know that we have a session to follow up. So how do you feel like looking back at the Galleria with all the stuff you know today? Better? Don't know? Okay, let's reveal that secret. According to what we see and what the OWASP stuff is saying, the Galleria didn't score that bad. But at the end of the day, you have a good idea what Java EE is able to capture out of the box without doing anything additional on top. One last remark, if there aren't any additional questions regarding the GlassFish and SAML stuff, you could look at least at the commercial distribution of GlassFish and look at what Oracle has to offer in terms of products. GlassFish as an open source product will probably never have that, but there are some decent integrations for the commercial version with all the Oracle Enterprise Manager and security things. If you're tied to GlassFish, then that is a good option. Thanks for listening. If you don't have any additional questions, then we are happy and hope you had a great time here. Thanks a lot.